Carl Skinner is a name synonymous with firefighting and forest management in the United States. He began his career as a firefighter in Lassen County in 1968 and went on to become one of the most respected and accomplished scientists in his field. After an illustrious career spanning 42 years with the U.S. Forest Service, Carl retired in 2014, leaving behind a legacy that continues to inspire those who work in the field of fire science today. Carl Skinner's contributions to the field of fire science are numerous and far-reaching. He is particularly interested in the interplay between fire and climate, and his research in this area has helped to shape our understanding of how wildfires behave and how best to manage them. His work has been instrumental in the development of fire management strategies that are both effective and environmentally sustainable.
Hello, I'm Carl Skinner, and I'm a retired research geographer. I worked for a number of years in research and fire management for the U.S. Forest Service, and then also worked for a number of years in fire management itself before doing that. And I'm going to be talking with you today about the broader picture of dealing with fire and fire hazard. From the landscape scale, landscape assessment and strategies, the basic principles of how to think about fire across broader areas, because we are getting a lot of pretty large fires these last few decades. And landscapes can be very different. Here we have the valley here in Northern California, and this is just north of Chico. Here we have foothills. They look very different, and they burn very differently. And there's the Cascade Range over north of Lassen. And here's the Klamath Mountains. All of these are very different places, and they actually interact with fire in very different ways. And so that's what I'm planning to talk about, because place matters. Keys to managing landscapes. The type and continuity of the fuel complex is key, especially the continuity of it. Type is important because different types of vegetation burn more readily than others do, but the continuousness of it makes a big difference. And then topography. The topographic complexity also makes a big difference in how fire moves across larger areas. So topography, you have the Klamath Mountains, and you have steep incised canyons and sharp ridge tops and so forth. And so fire runs uphill really easily and backs down more slowly. And you get different fire effects that way in landscapes like this. And you can have ridge tops where the fire is going to change its behavior and gives you places that you can probably try to corral a lot of fires. Here's the Cascades. A very different kinds of landscape. It's a very gentle landscape, and what you see is you don't have those sharp changes in a landscape like this. It's much more gentle and flowing, and so fire has a tendency to be able to just, once it gets going, especially if there's any wind or anything, it just keeps going unless it runs into or runs out of fuel, maybe lava beds or something like that. And so these two landscapes would work very differently with fire. And so a study that we did that tried to help us, that we wanted to look at did fire historically work in a landscape. It was one we did at over near Hayfork. This is Rouge Creek, Judd Creek, and then this is main Hayfork Creek. And this is just out of Hayfork. And then there's ridges in here. We have a ridge here, we have a ridge that bounds this, and then there's side ridges that come down. And so you have all these little creeks in here that break this landscape up. It's a Klamath Mountain landscape, is basically what you have. And we collected data at all these points to see how the ages of the trees were different in different places and how frequently fire burned there, and how large the fires would have been in the past before we started trying to think we could do better than Mother Nature. And when we finished with it, what we found was it gets broken up. This landscape was broken up into these different compartments, and the different colors show different places that burned like this red all kind of burned at the same time together, but it didn't go over into these areas very often. This area burned together, but not with this one. This one, there's a creek here, and then there's a creek here. And so these places were separate. And then this is interesting. It's kind of hard with the lighting, but this place and this place are on the same ridge. So why didn't they burn together? It's because we found out this has metavolcanic derived soils. This has ultramafic soils. They have different productivity levels. And so basically this one grew fuels faster than this one did. And so fires were more frequent and on different timing than they were here. And so these things is how the forest worked in the past. And only once every 100 years or so would a fire actually go across the whole landscape. So we call these fire occurrence groups, and they were defined by topographic features in most cases. Might give an idea how to approach the landscape today. So fire frequency versus severity. This is one thing that was interesting and something we didn't expect. What we found was it didn't matter where you were in the landscape, fire frequency didn't vary much. Every place used to burn fairly frequent in California because of our climate. And what we found was that severity patterns were what varied. And this is a chart that shows low severity proportion, moderate and high severity proportion in Thompson Ridge. This is up out of Happy Camp. And this was reconstruction from fire history. So this would kind of how that landscape worked. With most of it was burning at low severity and then some of it at moderate and very little at high severity. What's interesting about this is that in 1987, we had a huge outbreak of fires across Northern California. And here's what those fires did in Hayfork. Because most of this did not burn under severe condition, it was just because there was lots of fires and too much for all the fire crews to deal with. And what we ended up with was mostly low severity, some moderate, and not that much high severity. It was very similar to what the fires used to do. That's surprised us. But here's what the fires have a tendency to do more of today. Here's the Biscuit Fire from Southwest Oregon and came into Northern California. And it was a 500,000 acre fire, and yet half of it was high severity, where almost everything was killed. And then the rest of it was mostly moderate severity, almost nothing low severity in the Biscuit Fire. And then we can get a fire burning today under really severe conditions with the winds and continuity of force over the landscape. And here's the Fountain Fire that went over the Cascades. And it's 90% high severity. And this was mostly burned in one afternoon, by the way, in this huge fire. And very little of it moderate and low severity. And that's what we're dealing with in a lot of our fires today. And in fact, this is the proportions here are almost the same as what the Dixie Fire ended up with. Only the Dixie Fire was almost 1 million acres, twice the size of the Biscuit Fire. So what's important to understand is severity patterns. There is spatial context to it. And especially historically there was, and even today under more moderate conditions, like in 1987 fires I showed you, and in 2006 fires that we had that were burning just because lots of lightning, but not so much because it was severe conditions. They're not random. There is spatial context to it. And what we see here is a landscape that burned this entire landscape burned 5 years before I took this photograph, and it burned in the 1987 fires. This is Thompson Creek area up out of Happy Camp, and this is going up into the Red Buttes Wilderness. And what you see is a pattern that we see repeated again and again from our fire history studies. There's a greater proportion of high severity at the upper slopes, especially on west and south facing slopes, because fire runs uphill And when you're up here, it's more likely it's coming up from down below. And then we get a greater percentage of low severity in the canyon bottoms. And when fire backs down or comes down from above, it goes slower and it doesn't do as much damage usually to the forest. And so that's what we found there. And then mid-slopes are intermediate. And this pattern shows up again and again, especially on south and west facing slopes. And now I'm going to give you a chart that was looks a little busy at first, and hopefully I can explain it well. That has to do with slope position. But it's like this. This is lower slope on the south and west facing, middle and upper. And over here we have upper slopes, middle and lower slopes of the east and north facing slope. And what you see is the amount of low severity and moderate. And then as you reach the upper parts of the slope, you get much more high severity. But you go over the ridge to the north and east facing slopes and you get much more low severity. This was the opposite of what we were actually expecting to see. But this is what our data showed us was going on with a lot of these fires. This is based on the Thompson Ridge study again. And so it shows how it depends on where you are on the slope in the landscape and so forth as to what this fire is actually doing. And so here we go with fuel treatment patterns then. If you think about it, there might be places where you do your strongest fuels treatments, places where you do more minimal fuels treatments, and then the stuff that's in between is how you would approach it. Instead of doing the same thing everywhere, is think about where you are in the landscape when putting fuels treatments in. Now, environmental controls on fire. These are the things: climate, substrate, which is basically soil, that's your geology, and it creates the soils, and then topography. These are actually the main things that control what fire is doing. We can't do anything about them though. Basically, those are the things that are out of our control. What we get to deal with is vegetation. Vegetation makes a difference, but it also responds to all of these three things. And so that's what we get to work with. So spatial, scale, and context. Here's the stand scale. There's a landscape scale. It's combinations of a number of stands within, say, a watershed or something where fires might have a tendency to move through it. And actually that whole place burned in 2021 in the Monument Fire, I believe. And then here, these are regions and different kinds of conditions in general over larger areas that you see. And so basically you would approach, these are the Klamath Mountains, and you approach these differently than you would, say, the Northeastern Plateau as to how you would think about dealing with fire and such. And so then show you a picture like this. And which one are you going to treat? What are you going to deal with? Are you going to deal with this or this one? Well, actually, if all I do is show you a picture like this, that you don't know where that sits, means that you have no landscape context. You don't know where they are. You don't know what you're buying by dealing with this one or dealing with this one. And so let's look at it a different way. Which stand to treat? Well, this is in a place like this. It's got a lake on one side, rocks all around, and basically that's why it looks like that, is because fire doesn't get in there very much unless the lightning actually strikes right there. This is in the Castle Crags Wilderness. This is where this is. This one is a ridge top, a major ridge top that separates two big watersheds, the Deer Creek and Mill Creek watersheds, and it's in that Ishii Wilderness area. And this would be a major divide for fire being able to move from one watershed into another watershed, depending upon how conditions are. And so to me, it would be very important to try to maintain these conditions compared to spending a lot of money trying to go in here and do something in this area. So that's why landscape makes a difference. Also, the way fires move across a landscape depends on the kind of conditions of the forest. This is looking down on that place that's in the Beaver Creek Pinery, what it looks like from the air. And you can see young places, openings of young trees and mature trees and so forth, and that, but it doesn't have continuous fuel of any particular kind moving through this landscape. Compare that to this one. This is Stanislaus-Tuolumne Experimental Forest down near Yosemite. And if you look close enough at it, you can see the large old trees, the clumps of younger trees that were like this at one time that have now grown up because of fire suppression primarily. And now it's just continuous fuel across the whole thing, basically is what it is. It has been treated since I took this picture, but that's to make the point. And so, which one of these do you think fire retardant would be the most effective in? Here it's going to get to the ground and it'll be, and so forth, and interrupt the movement of fire across that landscape, potentially. Down here it's going to get hung up in the tops of the trees and it's not even going to make it to the surface in most cases. So those are just some of the things that these different kind of forests can affect when trying to deal with fire. Options. The other thing about depending upon how you've managed landscapes is there's a lot of options here in this landscape as to how you might be able to work with it and treat it and deal with habitat and so forth. But there's not a lot of options left in this one. It's pretty much turned into all the same thing. And that's after the fire went through, the fountain fire. And so basically, if you, like the Dixie Fire, and we just published this last summer, this paper, the Dixie Fire was just about 1 million acres, just shy of it. Over 500,000 acres was high intensity, high severity. And so basically, 500,000 acres of this is essentially what you got out of the Dixie Fire, which gives us very little options as to what we can do in the future. And you end up with, that's the fountain fire, by the way. And what the post-fire environment, what we're seeing happening is that, where's the seed source? You've got to go in and plant if you want something, trees that you might want in there or such, because there's no seed source left. And the local climate now, the climate near the ground where the little seedlings are trying to come up and plants are trying to grow, is open to the full sun. There's no shade anymore, anything like that, and they desiccate easily, and that makes it difficult for them to grow in many ways. And the other thing that we're seeing now is that places that burn severely are having a tendency to reburn severely before they can recover. And one of the things that seems to be leading to that is that everything out there now is going to be the same age, all growing up together. And when you get the conditions that allow fire to move easily through that stuff, say 10 years, 11, 12 years after the original fire, you got enough vegetation out there to carry fire again, the whole thing can go because it's all the same thing. Now it's all the same age, and once the conditions are such to carry the fire, it'll just go, and it makes it more difficult to redo it. So post-fire effects and spatial scale. The spatial scale of the effects are what are very important. And so you see here totally different scales, because this is the same period of time after a fire went through. Both of those photos were. And less high severity, such like this one, that really affects habitat in many ways. And because you have a whole lot of different kinds of conditions out here, whereas here, it's pretty much very similar conditions everywhere you look. So, time since fire. Okay, this is the fire year. Right after the fire, we went in and looked at it. There's 8 years after the fire, what you might expect to see. Fuels, things dying, falling down, and accumulating now, waiting for the next fire to come. There's 25 years after the fire. This is up in the Salmon River country after the 87 fires. And you know you're going to get intense fire out of that when it burns. And then here's a situation where the fire burned in 1987 and then came again in 2008 near Hayfort. So time since fire makes a difference, and it'd be hard for this place to burn for a couple of years, but then it accumulates and will burn pretty severely. So why do we worry about the broader landscape outside of the WUI? The WUI is where most people are in our homes, and that's what we really care about in many ways. So why do we worry? Well, this is one of those things that happens. This is in June 2008, and this is 2 days after lightning went through Northern California and started all these fires at the same time. And some of them are affecting communities, some of them are not, but they're all out there burning, and there are only so many fire crews. And so you can easily get overwhelmed, and you end up with this kind of thing happening where crews focus on fires nearing the rural towns and basically are almost ignoring the stuff going on anywhere else. But why do we worry about the broader landscape? Watersheds, that's where our water comes from. And that's where aquatic habitat is and such. Soils. The intensity of the soils and how much of it burns, the way that it burns can really affect the productivity, the amount of erosion, all kinds of things that are going on afterwards. And vegetation, the response of vegetation makes a big difference. And that leads us to wildlife and wildlife habitat patterns in landscapes. Recreation, people like to recreate, but it isn't a whole lot of fun to recreate in a place that's just totally open to the sun with lots of dead trees falling down. And historical and cultural resources, all of these things are concerns in the broader landscape. And fires moving from community to community. That's how they get from one place to another, even though that's not necessarily where houses are. Look at the Dixie Fire. It started somewhat near Paradise, burned up the canyon, and then took out Greenville, and then went to Chester, and ended up coming out of the north part of Lassen Park and towards Old Station. And so it's the broader landscape is what allows these fires to do all of this. And it depends on how they're managed as to how easily it is for them to get from place to place. Thank you.